Okay, so what we're going to be talking about today is credit card numbers. Now, this is similar to what we were talking about yesterday with UPCs. Basically, we're going to have a list of numbers that some have certain weights on them, while others have different weights. Now, it says identification numbers are present everywhere in society. Today's identification numbers are more sophisticated than those introduced years earlier, such as the Social Security numbers. Today's numbers have a check digit to partially ensure that they have been correctly scanned or entered into a computer. So it says credit cards have 16-digit numbers, of which the first 15 identify the credit card, and the 16th digit is the check digit. And so it says that MasterCard numbers begin with either 51, 52, 53, 54, or 55. And it's asking us, what is the maximum number of credit cards MasterCard can issue? So I'm going to write out, we know that a credit card has 16 numbers. So I'm going to say numbers, or 16 digits. So there's 4, 8, 12, 16. And I know that the first digit, so MasterCard can only issue cards starting with these numbers. Well, if you notice, the first digit on each of these is the same. It's just a 5. So that first digit in this card number only has one option. Okay? It's a 5. And then the next number, it could be 1, 2, 3, 4, or 5. So the second digit has 5 options. And then the last digit down here, this last digit is our check digit. This is specific. It can only be one specific number, and the reason is because all these other numbers determine it. So this, our check digit, only has one option. Now the rest of them, they don't have any restrictions. These can be whatever they want. So we've got numbers 0 through 9, which means we have 10 possible outcomes for each of these digits. And so if we multiply all of these together to find our total possible number of credit cards that can be issued, we've got 1 times 5 times, if you count these up, we've got 10, we've got 13 tens. So 10 to the 13th and then times 1 at the end. And so our final answer is going to be 5 times 10 to the 13th, which is the same thing as 50 trillion possible credit cards. So it's safe to say that MasterCard is not going to run out anytime soon. All right, so it says a check digit is used to help validate credit card numbers. The credit card companies use the Codebar method to determine the check digit. This method consists of the following steps. So we've got, first step is to add the digits to the odd numbered positions and double them. So basically 2 times odd numbers, or odd digits. Add the number of odd position digits that are more than 4 to the total. Add the even position digits, and choose a check digit that makes this calculation a total number whose final digit is 0. So the first thing they tell us is show that the check digit D for the Visa card, this right here, is 3. So I'm going to break this into 3 different steps. Okay, so the first step, it said 2 times all odd digits. So I'm going to underline all my odd digits. So I got 4, 6, 0, 1, 3, 5, 7, and 9. Okay. And I'm just going to do 2 times all of those. So I've got 2 times 4 plus 6 plus 0 plus 1 plus 3 plus 5 plus 7 plus 9. Okay. So this is our step 1. And then step 2 said I add the number of odd position digits that are more than 4 to the total. So if we look, we've got 6, we've got 5, 7, and 9. So we've got 5, 7, and 9. So any of the numbers that you underline in step 1, if they are greater than 4, it goes towards step 2. So we got 1, 2, 3, 4 values. Okay. And then the next part, it tells us we want to add the even position digits. So all even position digits, I got 1, 2, 0, 2, 4, 6, 8, and D. So I got 1, 2, 0, 2, 4, 6, 8, D. Okay. And then the last thing I want to do is I just want to simplify. So I'm going to have, or excuse me, let me do this real quick. So this was step 2. And then the last one was step 3. Okay, now if I simplify, I got 2 times 35 plus 4 plus everything that's in there is 23. And then I'm just going to pull the D on the outside, so I've got it like this. And if I simplify more, add all this up, I've got 97 plus D. And D has to be a number such that the entire thing ends with a number, or excuse me, equals a number that ends with 0. So the next highest number that ends with 0 after 97 is 100. So D has to equal 3. The next part, it says, what is the check digit D for the MasterCard number? That right there. So we need to figure it out. So again, I'm just going to take 2 times all of my odd digits. Okay, so I'm going to have 2 times 5 plus 2 plus 9 plus 1 plus 2 plus 2, and then plus 0 plus 8. The next part, I'm going to count up all the odd digits that are greater than 4. And so if you count them up, you've got this 5 right here. That's an odd digit greater than 4. I've got the 9, and then I've also got the 8. So I've got 3 of them total. And then the last part, I'm just going to add up all the even digits. So I've got 4 plus 8 plus 3 plus 7 plus 0 plus 0, and then our D. And so I've got 2 times 29 plus 3 plus 26 plus D. And so that should equal 87 plus D, which means D has to equal 3. Okay, because remember, this whole thing has to add up to a number ends in 0. The next highest number like that is 90. So to go from 87 to 90, you have to have 3. And then part 4A, show that that number is an invalid Visa credit card number. So again, I'm going to do the same process, 2 times my odd values. So I'm going to have 2 times 4 plus 2 plus 0 plus 1 plus 4 plus 8 plus 0 plus 1 plus step 2, I add up all the odd digits that are greater than 4, which in this case I only have 1, which is this 8 right here. And then the last part, add up all my even digits. So I'm going to have 1 plus 8 plus 0 plus 2 plus 3 plus 9 plus 1 plus 0. So this will equal 2 times 20 plus 1 plus 24, which all should equal 65. And the reason this doesn't work is because it's not a number that ends with 0. So we can say this is invalid because it is a number that does not end with 0. Part B, it says if someone made a single digit error when entering this invalid number, can you tell which digit is incorrect? And so we've got all these numbers up here, and almost all of them could be any number from 0 to 9. The only ones that can't be like that are the first two and the last one. So we have 9 digits here that could be anything from 0 to 9. If I were to change one, do you think you'd be able to tell which one is incorrect? Well, if I have 9 possible digits that I can change into 10 different numbers, it'd be kind of difficult to pinpoint which one is exact, because I could change any one of them and you won't really be able to tell. So it's asking, can you tell which digit is incorrect? Why or why not? No. And the reason is because any single digit could be changed to make the entire number not equal 0 and become invalid. So you change any one of them and it'll mess it up. And it's not very possible to figure out which number it is that I changed. And then the next part, change one digit that is digit in this invalid number so the resulting number is valid. So you can either, I would focus on the even digits over here because they don't have a multiplier like the odd digits do. So look at your final value here. We got 65. It needs to be a number that ends with a 0. So you could either make this, try and shoot for this to be a 60, or you can try and shoot for this to be a 70. Whichever one is fine, they both end with a 0. So I would look at these and see, okay, you could either add 5 to any of these so long as it's still a single digit, or you can subtract 5 so long as it's still a single digit. So for example, you could look at this 1 right here, which is actually the second one, or it's the first one in the list of numbers. It's the second number total. You could add 5 to this and make this 70 at the end. Okay, so an example of this would be,
Students, as a reminder,
sorry about that, the alarm was going off, but so an example of this would be you could change the first one to a 6 because we added 5 to it. Another thing you could do, instead of adding 5 to this 1, you could maybe subtract 5 from this 8. So that first 8, so we could say change the first 8 to a 3. We took 5 away. Okay, and there's multiple examples you could do, but those are just 2 of them that I thought of at first.